Hello, welcome to today's lesson on interval notation. So a lot of you in the past have learned what I call alligator notation or inequality notation when we're talking about a set of numbers. And in pre-calc and calc, we're going to use interval notation a lot. So some of this was covered in Algebra 2, but I want to give you all a review so you're ready to go with it. Let's take a look at some examples. So over here, we have our basic interval notation where we've got x is greater than or equal just greater than 3. So just in case you're not familiar with interval notation, let's see what that actually means on the number line. So in this case, it's saying x can be any value past 3, but it does not include 3. So we put like a hole right there, so an empty circle. If this were colored in, it means we include 3. But no, it's not. So like 3.000001, that counts. It's bigger than 3. But 3 itself and anything less than 3, x can't be that. So our way of saying it's bigger than 3 but not equal to is to not put a bar underneath it. And I call this alligator notation because when I was in grade school, we learned that the alligator eats the bigger numbers. So you imagine that being like an alligator eating something there. So x is bigger than 3 because the alligator is eating the x. So what if we wanted to say something like x is greater than -1 or equal to -1? Well, we'd write this out as x is greater than or equal to -1. That bar underneath means include the -1. And then we would fill it in right here like this. It would be a solid and it'd go that way, meaning all numbers including -1. So this is on the number line. This is represented, that right there is what we call inequality notation. Inequality meaning not equal, something's bigger than something else. But what we want to learn today is interval notation. So interval notation works like this. Down here we have -infinity, and over here we have infinity. And we use commas and parentheses and brackets, okay? And they all have their different meanings. So for something like this, when we want to include a number, we use a bracket. And for something like this, when we don't want to include that number, we use a parentheses. So for instance, x is greater than 3 would work like this. We work from left to right, and we don't want to include the 3, but we're going to tell somebody we're going to start at 3, going left to right. Don't include the 3. That's why we've got the parentheses. And then go off to infinity. Now, whenever we have infinity or negative infinity, we always use a parentheses because infinity is not a number, so you can't include infinity. So, what this reads is, x can be anything bigger than 3. I know what you're thinking. You're saying, well, that's pretty complicated. Much easier to read this. But it does make things easier later on. At least I think it does. Either way, you got to know it, okay? So 3 to infinity, that's how you write it. For this one, we want to say everything bigger than -1 and equal to -1. So going left to right on this chart, we're going to start at -1 and include it. So we're going to write it like this to say include that -1 and then go on forever to infinity and beyond, right? There you go. So that's how we say anything greater than or equal to -1. That's how we say anything bigger than 3 or greater than 3, but not equal to 3. Let's take a look at this one. This one says x is greater than or equal to 3. So drawn out on the graph, it would look like this. Solid bubble here because we're including the 3 at the bar underneath it. And we're going to go to all numbers larger than that. So in interval notation, we want to start at 3 going left to right, and we go to infinity. Always go left to right. We don't say from infinity to 3 or read it that way. You move from negatives to positives or smaller numbers to larger numbers. Now, sometimes we start to get a little more complicated. So this says that x is in between -4 and 2. And can equal to because of the bar there. So let's look at that on the chart up top. So it says x can be larger than negative 4. So here's 4. Do we shade it in? No, because there's not a bar there. But it also says that it must be less than 2, or it could be equal to 2. So less than or equal to 2, so we can include the 2, so put a bar, and it's all numbers in between. Okay? So that's how we represent it on the number line. This is in alligator notation. Now we want to put it into interval notation. So go left or right, we pick up with x values just above negative 4. So don't put negative 3 here. That's a common mistake because you think, oh, you can't include negative 4. But remember, negative 3.9 you can include because that's bigger than negative 4. So we're going to write this as don't include. That's what the parentheses mean. Start at negative 4 and then go all the way up to 2 and then include the 2. So once again, start at negative 4, do not include it, go all the way up to 2, and then include it. That's how we would write that in interval notation. All right? We're going to try out several examples. Let's look at another one here. So this one in alligator notation, we'll draw down the number line first. It says x can be greater than or equal to 3. Here's 3. We're going to shade it in because it can equal it. And it's going to go on forever that way. It can also be less than but not equal to negative 2. So leave that open because it's not equal to it, and it's less than. So here's a case where we have, it's a little bit different. You know, it's not connected like our last example. So I'm going to start from left to right and write this out. I'm going to say, all right, we're going to come from negative infinity, because remember, we're going from this way on. So it starts all the way over here in negative infinity and goes all the way up to negative 2, and we don't include it. Then it jumps and picks back up at 3, and we include the 3 because it's shaded, and then we're going to go all the way to positive infinity. So this is how we would write this out up here. Don't include negative infinity because it's not a number, but start there. Go all the way up to negative 2. Do not include the negative 2. Skip to 3, include the 3, and then go off to positive infinity. Don't include positive infinity. Now, if you're doing something like a Delta Math assignment, that's what I'm currently using for my assignments. It may be something else by the time you're watching this video. They're going to want to see this symbol right here. It means union. Okay, and that will be an option that you can put in there. As far as your quizzes and tests go, as long as it's not in Delta Math or a programming that requires it, I'll let you know before you take the assignment if it requires it or not. I don't care if you put the union in there or not. I know. I'm breaking rules here, right? So if you just wrote it like that, if it were a test and I'm grading it by hand and not the computer automating it, I don't care if you put the union in there. All right, next one. This one says all reals. So if we're drawing this one out, it just looks like this on the number line. It includes all reals. So how do we write this in interval notation? Well, we start at negative infinity, don't include it, and we go all the way out to positive infinity. And that's it. That means all reals, negative infinity, infinity. Parentheses, don't do brackets or you get it wrong when it's infinity attached there. All right, let's look at another one. This one says all reals except for negative 2. So this is how we would draw this one out. Right here's negative 2. There's a hole right there. And we're going to go to positive infinity that way and negative infinity that way. Notice the difference the way those look at. This one, or look like, this one is all reals. This one is all reals except for negative 2. So when we write this out, it's going to kind of look like this, but we've got to say get rid of the negative 2 in there. So we start at negative infinity, go all the way up to negative 2, and don't include the negative 2. Then we're going to pick back up at negative 2, don't include it, and go to infinity. And once again, if you're on that computer program, you're going to put a U in there for union. All right, you're uniting those two. But that's how we would write out in interval notation everything except for negative 2. Let's look at one more here. And this one says all reals except for negative 3 and 1. So this time, once again, we're including all the numbers, but now we're going to throw out two numbers. So this is going to get longer and longer, our interval notation out here. So if I was writing this out, I'd say, okay, there's a hole at -3 and there's a hole at 1. And we're going from negative infinity, skipping over 3, going all the way up, skipping over 1, and then going off to positive infinity. So that's what I need to show in my interval notation. If it helps you, you can write it up here. You can say, go from negative infinity all the way up to -3. Don't include the -3. Pick up at -3. Go all the way over to 1. Don't include that 1. Then pick up at 1 and go to infinity. Okay? So this says skip over -3, skip over 1, and then go to infinity. And then, of course, we're going to put the union in between them. Okay? So that's our answer for that one. That is interval notation. Okay? And you say, why on earth do I need to know this? Well, we're getting ready to talk about domain. And domain is our possible x values that a function can take on. And so we're going to express our domain in interval notation. Later, we're going to learn about range and express our range in interval notation. And then we're going to talk about increasing and decreasing values, and we're going to have to express all of that in interval notation. So do the practice, ask me questions if you have any, and I'll be happy to help you. Thanks for watching.